All right, so something I want to clarify. We kind of split up factoring a little bit differently than we did last year. So the numbering of our notes, I just want to make sure are clear. That yesterday you had 6.4 AA notes. Today is 6.4 A, single A. The reason why that's important for you to know, first off, where does the 6.4 come from? Do you know? From your textbook. That's Module 6, Lesson 4. So if you needed to go back and look in your book, it's Module 6, Lesson 4. That's what those numbers mean. And then your homework assignments, last night's worksheet was AA, tonight's is A. So that's important for you to note because you need to make sure that you're submitting the correct worksheet into the correct assignment on Google Classroom. Okay? All right. So we are still following the same step number 1, which is what? Check to see if they have anything in common. If they have something in common that you can take out, it makes your numbers smaller and it makes everything easier. So we're going to start with this guy right here. And the first thing I noticed about this guy is there's both a W and an X. We didn't have that yesterday. We had only single letters, didn't we? So I'm going to show you what to do with that. Do you notice that the W's and the X are kind of like mirrors of each other? In that I have W squared here, I have X squared at the end. In the middle I have one of each. Yeah? So, let's see. In the letters, W's and X's, do they have anything in common that I can take out? Nope. 2 terms have a W, the third one doesn't. 2 terms have an X, the third one doesn't. Can't take anything out there. What about the numbers? 15, 83, and 112. Do they all have something in common? My brain wants to say 3, but I don't think 83 is divisible by 3. Nope. So I don't know that there's anything I can take out. So I'm going to go to my snowflake with these giant numbers and see what we can do. Okay? So what's going to go on the top? 15 times 112. That's going to be a big number. 1680. And on the bottom, what am I going to put? Negative 83. Now I need 2 numbers that multiply to get 1680 and add to get negative 83. Every now and then you're going to get a big number like that, like 1680. And at this point, we just guess and check. So I'm going to try some guessing here. If I did 1680 and I divided that by 2, I know I'm going to get something that's way away from 83, right? I like to go by even numbers when I have numbers that are even because I know it's going to be easy to divide. Divided by 4, 4 and 420 is not going to get me 83. I'm going to jump a bit because I'm not very close, am I? If I divided by 10 and 168, still not going to get me 83, a little closer, but not that much closer. What if I divided by 20? 84 and 20, not going to give me 83, but still getting closer. Can I divide by 30? 30 and 56, a lot closer, right? So I'm going to slow down now, maybe 32. Nope, gave me a decimal. 33, nope. 34, nope. 35, oh, there's promise. 35 and 48, would they get me 83? They would. So 35 and 48, how would they get me negative 83? If they were both negative. So negative 35 and negative 48, when I multiply them, will get me that positive. And when I add them, will give me negative 83. So I'm good. What do I put on the top? 15W and 15W. So I'm taking that W and I'm splitting it up, right? Now let me show you how to deal with the other exponent, or the other variable. Since this is x squared, I split the w's up and put them up here. I'm going to split the x up, or the x squared up, and that's going to go on the bottom numbers. Now, can I reduce this? I think I can. 15 fraction button 35 reduces to 3/7. Notice how I'm using my calculator to help me. It's amazing, isn't it? So that gives me 3w over negative 7x. I'm going to do the same thing over here. 15 fraction button 48. Don't worry about the negatives or the letters right now. That reduces to 5/16. So I would put 5w and negative 16x. Now I know they're reduced as far as they can go. So what are my two parentheses? One of them is 3w minus 7x, and the other one is 5w minus 16x. Does it matter if your answer has 5w minus 16x first and then 3w minus 7x? Nope. As long as my two parentheses are your two parentheses, it doesn't matter which order you write those parentheses in. Okay, questions there? Okay, moving on. Looking at this guy. Okay, I have that two letters thing. I know what to do with that though now with the snowflake, right? I just put that second letter down here. But I only have two terms. So I could snowflake if I wanted to, and if I snowflaked, 49 is my A value. What's negative 225? Is that B or C? That would be C because it doesn't have an A in it, does it? So that would be C. What's B? 0. So I could snowflake like that if I want to. But I could also recognize that when I have two terms that are connected by subtraction, that I'm going to want to check to see if I have a difference of squares. Because that can be a nice shortcut for me. And this one I believe is a difference of squares. How do I know? Well, I know that there's a number that when I square it gives me 49. What is that number? 7. And I know that there's a number when I square it gives me 225. What's that? Anyone know? 15. So, the square root of 49a squared is 7a. So in the beginning of each parentheses, I write 7a. Again, you can use snowflake if you want to. This shortcut is way faster. Because truthfully, 49 and 225, I don't want to multiply on the top of my snowflake. What's the square root of 225b squared? 15b. And the difference of squares rule says make one of them a plus, one of them a minus, and you are done. Easy peasy? Okay. Let's look at this one. Is this a difference of squares? 81 is a square number. Is c to the fourth a square number? It is. Any exponent that is even is a square number. This is c squared squared. Okay? If I had c to the sixth, what's the square root of that? C to the third. You just cut it in half to find what the square root is. If I had c to the 14th, that would be c to the 7th. So anytime you have an even exponent, you can break that down into a square. So, if I use my difference of squares rule, the square root of c to the fourth is c squared by cutting that 4 in half. The square root of 81 is 9. Make one a plus, one a minus. I'm done. No. Why am I not done? They're both still squares, but only one of them makes a difference. Because this right here is a sum of squares. The sum of squares I can't do anything with. But I have another difference of squares here, don't I? I can take the square root of that. I can take the square root of that. So that gives me c squared plus 9. And then c and 3. C and 3 make one a plus, one a minus. Now it's kind of frustrating that we can't do anything with that sum, but it is what it is. Okay, questions there? Okay. I am going to skip this one for the time being. I'm going to go down to this guy, and then I'll come back to that other one. Now, do they have anything in common that I could take out? Nope, nothing in common. This almost looks like something I should be able to go to my tree or my snowflake with, doesn't it? Except there's a problem. What's the problem? It's not x squared. It's x to the 6th. Well, here's the deal. I can use my snowflake and treat it because it actually is in quadratic form. Here's the one rule. This exponent, when you cut it in half, must give you that one. If that is true, you have something you can snowflake. It's in quadratic form. So if my first exponent was 20, the second one would have to be 10. If my first one was 8, the second one has to be 4. As long as it follows that pattern, you can snowflake. Excuse me. So, let me show you what that looks like. This should be a pretty quick snowflake, though, because the numbers are pretty small, right? What goes on the top? 1 times negative 8 is negative 8. What goes on the bottom? Negative 7. Two numbers that multiply to get negative 8 and add to get negative 7. Negative 8 and positive 1. Right? Now this is the only trick. How do I split up x to the 6th? I want to split it up evenly, so I give x to the 3rd and x to the 3rd. You just cut it in half. Okay? Can either of these two fractions reduce? So I have x to the 3rd minus 8 and x to the 3rd plus 1. Am I done? I see two terms and two terms. My brain should be thinking, is there a difference of squares? But I don't have a difference of squares because both of these are cubes, right? Now, in a couple days, we will be able to take that further because we're going to learn how to factor a difference and a sum of cubes. But for today, we're just going to leave that right there. Today, we only have difference of squares. Okay? All right, now this last one is kind of combining some things. Do you notice it has two letters? And the second letter has that squared. So I know what to do with that, right? Just what I did up here by putting it on the bottom. I also have this first one following that halfsies rule, right? So I can use my snowflake. Before I use my snowflake, I want to see if there's anything I can take out. What do they have in common? 4. Anything else? No. 2 have x, 2 have y. All right, so 4 times x to the 10th plus 10x to the 5th y plus 25y squared. And that's what I'm going to be snowflaking. So if I snowflake that, 1 times 25, I have 25 on the top and 10 on the bottom. Oh, that's an easy one. Yeah, 5 and 5. So, because this is x to the 10th, what do I put on the top here? X to the 5th. And because there was a y squared at the end, what do I put on the bottom? A y. If it was a y to the 10th at the bottom, what would I put at the bottom? I'm sorry, a y to the 10th over here, I would put y to the 5th. I just split up whatever it is. Okay? Can either of these reduce? Nope. So I have a 4 out in front. I cannot forget that 4. And then I have x to the 5th plus 5y. And then x to the 5th plus 5y. Can I write that any better? I can write it as 4 times x to the 5th plus 5y squared. Now, what happens if I forget the 4? Well, the whole point of this is that, I mentioned it briefly on the video yesterday, if you were to multiply all of this through, you should get what? The original problem, right? If I didn't have the 4 and I just multiplied this, would I get the original problem? No, I would get this step of the problem. I have to include that 4 in order to get back to the full original problem. Okay, so don't forget that first guy. All right, any questions? Yes.
Would it be marked wrong if you didn't put it in that form like with the square, like and you just left the 2 out?
As in you put this as your answer?
Yeah.
I would probably take off 1 point there. Not full points, because you obviously know what you're doing, but we want to try and get to here. Okay? Again, your homework tonight is worksheet 6.4a. Happy studying.